We hear the question all the time, do we really have to worry about the Aldyl pipe in our gas distribution network? Great question, but to answer it, we really need to look at what Aldyl pipe is. Aldyl pipe was a brilliant invention by the DuPont Company in the late 1960s, developed to fix issues of metal pipe corrosion within the gas distribution industry. Since Aldyl is plastic, this eliminated the problem. In fact, Aldyl and all the different plastic pipe materials that came after it has significantly reduced leaks in gas distribution and has really enhanced the reliability of these pipelines. All of the Aldyl resins were marketed as one name, Aldyl A, but Aldyl A is not really one thing. There have actually been 5 generations of Aldyl A pipe. We still call each one Aldyl A, and that's where it can get confusing. When a king or queen dies, at least we put a 1, 2, or 3 after the names of the heirs that follow. It helps with royalty, but not so much when it comes to pipe. Really quickly then, the 5 types of Aldyl A are Aldyl 5040, 1965 through 1971. Aldyl 5043, 1971 through 1983. Aldyl 5046C, 1983 through 1986. Aldyl 5046U, 1986 through 1989. Aldyl 5046O, after 1989. Now that you have all that, let's throw in a kink. In the first 2 years of production of Aldyl 5043, that's 1971 and 1972, a manufacturing issue resulted in degradation of the inner pipe surface. Pipe produced with this defect has been termed low ductile inner wall, or LDIW. The LDIW pipe has noticeably lower performance than the Aldyl 5043 materials in general, particularly in regards to rock impingement, bending stresses, and squeeze off. The problem is, at the time, DuPont didn't understand the manufacturing defect, which means only about a third of the pipe made in that time was made incorrectly, and nobody knows what third, which means it's even harder to manage. If you have a sample of pipe made at this time and want to know if it is LDIW, cut the pipe in half down its axis, take a small piece of that, and then bend it back. If it has tiny crazings or cracks where you bent it back, it is likely LDIW. So, we have 5 generations of Aldyl, made from the 1960s to the 1990s. And we have 2 years of pipe somewhere in the middle, which really has us scratching our heads. We call it all Aldyl A, but the 5 generations do not all behave the same. The biggest difference between the generations of Aldyl, from an operator's perspective, is the slow crack growth resistance of the material. That is because a crack is the way the pipe will eventually fail. So if everything else is the same, the better the slow crack growth resistance, the longer the pipe will last. That would be wonderful if that were the bottom line, but in reality, some generations of Aldyl pipe just perform better than others. Further, the age of the pipe clearly determines when it will need replacing. So the situation for an owner of a pipeline is complex, and the solution is specific to the asset in the ground and a number of key variables specific to that asset, like temperature, pressure, installation quality, jointing, and so on. For asset owners, Jana can provide the answers you need as to the remaining life in your Aldyl pipe. This will help to prioritize the replacement of the pipe that is at the end of its life cycle and plan for the replacement of any Aldyl pipe that still has some reliable time left in the ground. Ask yourself, what type of Aldyl pipe is in your system?